Welcome to Study Loop.
This question asks us to calculate some energy associated with phase changes. So in this case, the phase change is vaporizing or boiling water. And we're provided with some information here that the density of liquid water is 1.00 grams per milliliter, and that we have a 100.0 milliliter sample of water. And we're asked then to determine, based on that sample, how much energy is required to vaporize it. So the first thing we need to know is what is the mass of that sample. So we can use the density information. It's a 1-to-1 ratio here, so we can see that we would then have 100 milliliters would convert to 100 grams of water. Okay. Now, where do we go from there? Well, we looked up the constant here for the enthalpy of vaporization of water, and we found that it requires 40.65 kilojoules of energy for every mole of water. Well, we know how many grams of water we have. We need to find out how many moles that converts to then. And so we need the molar mass of water. So the periodic table is going to help us with that. And when we look it up, we're going to determine that we have 18.0 grams per mole for water. And just to make sure we're clear on that, if this is what we do on the periodic table is we would utilize the two hydrogens, and the molar mass for each hydrogen located below its elemental symbol is 1.01 grams. Oxygen is 16.0 grams. Put them together into 3 sig figs. That gives us that 18 grams per mole molar mass of water. All right, so let's continue the calculation. So we have 100 grams of water, and that is 18.0 grams per mole of water. And if we crunch the numbers here, that will tell us how many moles of water are in that sample. So that gives us 5.56 moles of water. So what else do we know? Well, let's go back to that enthalpy of vaporization where the water is, where the vaporization of water and the energy is brought into this equation. It takes 40.65 kilojoules of energy to vaporize every mole of water, and we have 5.56 moles of water. Therefore, we should be able to determine how many kilojoules of energy are associated with vaporizing that water from this equation. So the final piece of our calculation gives us our final answer here. Based on that many moles of water, will require 226 kilojoules of energy to fully vaporize that water.